Hello and welcome back to my channel. Today we're exploring linear and transverse magnification, the secrets to how lenses bend light to make things look bigger or smaller. So first, let's discuss what transverse and linear magnification is. So both of these terms define as the ratio of the image size or image vergence to object vergence. So our formula is image over object, or it is equal to the dioptric power for the object over the dioptric power for the image. Or it may be simply V over U, where V is our image distance and our U is our object distance. Later on in our discussion, we'll get to know how we get these variables. So what are the similarities of these terms, transverse and linear? So both are measures of how much an optical system magnifies an object. Both are expressed as ratios with a value greater than 1 indicating magnification and a value less than 1 indicating reduction or minification. Both can be positive or negative, with positive values representing upright images and negative values representing inverted images. So, what are the differences in scope? So, in transverse magnification, it considers all overall size of the image compared to the object in any direction, perpendicular to the optical axis. So this includes the height and the width. So that's why for the formula of transverse magnification, we have m is equal to height of the image over object. And this formula is just in disguise for the transverse magnification of mt is equal to v over u, where v is the distance of the image and the u is the distance of the object. So they are more or less related with each other. Uh, Later on, you'll get to know the relationship based on visualization of this. Okay, and then for the linear magnification, it is a type of transverse magnification that focuses specifically on the magnification along the optical axis. This typically refers to the height of the image and object. So for the formula of linear magnification, we have m is equal to h over h. Okay? So the same ra siya atong sa transverse na h and then h. But in this linear magnification specifically, it includes the image distance and object distance. So it considers the distance. Whereas transverse, it is more of a general formula. They are more or less the same formulas, but sa linear kay Yaki emphasize ang height and distance. So let's go back to the transverse magnification and let's have an example for transverse magnification. For example, if the image height is 20 centimeter and the object height is 5 centimeters, find the transverse magnification. So all you have to do is to divide it. I over O. Since mo man ang general rule, general formula for the transverse magnification. Transverse magnification is equal to image over object. Okay. So here we have 4 times. So your transverse magnification is 4 times. Okay. Let's proceed with the example for linear magnification. So you need four givens. So you need the height and the distance for each of the object and the images. So with this given, we can simply substitute it and get the magnification. Okay. Don't forget to distinguish between the linear and the transverse. When we say transverse, it is denoted by the large M, while in linear, it is denoted by the smaller m. Okay, let's proceed with transverse magnification as a whole, or the resultant linear magnification. So, for example, if an object is placed 20 centimeter in front of plus 8D lens, what will be the resultant linear magnification? So this is what it looks like. So what is u again? That is our object distance. U, object distance. Object distance. Object distance. And then for our v, this is our image distance. These are the distances because mo man ang ato object, then mo ni ang iya distance. And then this is our image. This is the distance. And our p here is the lens. It is the contributing factor for the power. Okay? So an object is placed 20 centimeter. Muna siyang ato example na kanina. So to find the transverse magnification, TM, hindi ni si TM or MT, depende ninyo. Pero mas formal siguro ang TM. Okay. So let's just substitute it. Okay, an object is placed 20 centimeters in front of the 8D lens. So, kini daw kina na object kigi-place in front ani nga 8D lens. So, by that, we can say na ang P na to is equal to 8 diopters. And then for our U, or other object, so mana siya ang 20 centimeters in front. Okay. Okay, muna na siya. Oh, di ba? Iaragi encode. So we have here nanatay P and we have our U. But we can still solve for the transverse magnification since our transverse magnification requires the value for our V. So how do we solve for that? So that's where our U plus P equals V comes into play. So what is our U? That is our power for, that is the vergence of incoming light. So ano na siya? Vergence of incoming light. While our P is the contributing power for the lens. And our V here, the big V, is the vergence of the exiting rays. Okay, the exiting vergence. So how do we solve for that? Oh, first things first, day, you have to know that capitalization matters in this subject because when we say big U, it is not equal to the small u. In fact, it is this reciprocal value. Just like how we solve for the focal power is equal to 1 over f, which is equivalent to here. And for our u, siya, and our v is equivalent to 1 over small v. Okay? Okay, let's proceed. So, this is the formula. U plus P is equal to V. So since wala man tay big U nga na value, so U is equal to 1 over U, so 1 over U. So since centimeters man siya, so mahimo siya og 100 over negative 20. So nganong nahimo man siya negative 20? Because as what in the example stated, it is placed 20 centimeters in front of the 8D lens. So that means that it has a vergence, the converging vergence, which signifies for the negative value of 20. Unless if, ang sa example nga rin kay, an object is placed 20 centimeter at the back of 8D lens. So, nana siyang ritapita, which may signify that it is a positive value. But since placed in front man siya, so it is a negative value. So we have here 100 over minus 20 is equal to minus 5D. So, unsa man ning minus 5D? How do we interpret this? Since minus 5D is equivalent to 1 over U, so therefore, our minus 5D is equivalent to our U. So, nanatay value sa to U, which is minus 5D. And then sa P, simply substitute it lang, plus 8D, plus 8D, plus 8D. So, that. Okay. So, makakuha na ta sa ato V. Since same naman silang values, mga DD naman. So, negative 5D plus 8 is equal to 3D. So, you have the value for V. So, can we now solve for this equation? Still no, since big V pa man siya. So, to get the small v value, so, balik na sa tangari, big V is equal to 1 over small v. So, 1, okay. So, since centimeter man ang sa U na ito gigamit niya rin, so, pwede sad mangita ta sa U sa centimeter. So, 100 ang nasa taas. 100 over 3. As manigay ka ng 3 sa V value na to. So 100 divided by 3 is 33.33 centimeters. So can we now substitute this value? Can we now solve? Yes. So MT, okay. So MT is equal to V over U. So where V is 3.33. So muna siya. And our U, gikan nga rin, kini. So 20. So our final answer would be the transverse magnification is 1.67 times. Okay. Okay, let's proceed with, is this another example? Okay, this is an alternative solution in case that you're not comfortable with the small v's and u's. So, mas mubo ni siya gamay. So, all you have to do is MT is equal to U over V. So, asa man gikan ang big U over V? Naani siya gikan sa first formulas, di ba? Gamit na siya. Okay. Image over object. So, A is equivalent to U over V, and U over V is equivalent to V over U. So, how is this mathematically correct? So, since MT kanina is MT is equal to 1 over U. Oh no, V over U. V over U. Small niya, small. Maraming siya dako. V over U. Since small v is equivalent to 1 over v, divide pa gid siya sa large V ni siya. 1 over big U. So, lain siya kitaon, di ba? So, mo na, ni-arrive ta og U over V. Kaya ang reciprocal values man kay gihimo siya ginani. So, U over V. Okay, since now we know that the small v over u is equivalent to large u over v, so we can have an alternative solution. Pero if for you kanang ma-overload overload na inyo knowledge, if mas maglibog mo, you're free to skip this segment and proceed to the next topics, okay? Or the next examples. Okay? So this is just an alternative solution. So same process, pero kutob lang kaaning sa 3D. Okay? Kutob lang kaaning sa 3D. Since na naka-value sa U, which is the 5 diopters, and the V is 3D, so makadiretso naka-substitute. So U is our 5D here, and the 3D is here. So 5 over 3 is equal to 1.67. So it is the same with the previous solution. Di ba? Same ra sila. Dahil lang sila units, diopter na ni siya tungod kay ang Virgins power man ang gigamit ani, walang kini kay ang distance. So you will arrive with the same answer again. Okay, let's proceed to another example. So an image is perceived from a 30 centimeter distance using a plus 10D lens. What will be the resultant linear magnification? So based from the given, so we can draw this out. UPV, so maguna jud ang object, then power and the image distance. Okay? So image is perceived from a 30 centimeter. So with that phrasing, makaingon ta na ang ato V is equal to 30 centimeter. And our power, which is the lens, is equal to plus 10. So maka-answer na ba ta ni? Diretso? Gamit ang kining MT is equal to V over U? No, because wala pa tayong value sa ato U. So ang U na sa dato pangitaw na ni. Okay? So here we go. So same lang gihapon, U plus V, U plus P is equal to big V. So all you have to do is substitute lang sa U plus 10D and then 100 over 30 since centimeter man siya. So all you have to do is simplify it. So 100 over 30 is equal to 3.33D. Then transpose the 10D. So mahimo siya negative 10. So 3.33D minus 10D is equal to negative 6.67. Okay? So now we have the value for our U. So ang ato gusto pangitaon kay ang kining small u. So u is equal to 1 over u, so equals to 100 over 6.67, which results to negative 15 centimeter. So we can interpret this negative sign of our answer because the u here or the object here is placed in front of our lenses. So manong iya distance. But in a reality, in practical world, so ato na siya absolute value. So MT is equal to V over U. Asa man gikan ng 30? Kini. Asang gikan ng U? Kini sad. So, ma-negative yung answer. That just depicts that the object is in front. And then our final answer would be the absolute value, which is the 2 times. Okay? So again, we have here an alternative solution. So I'll be skipping this. You can skip this if you want to know what this is about. And then next we have the effective magnification. We have the formula of effective magnification is equal to the product of reference distance in meters to the object times the focal power of the lens. So Hikuray times. So, for example, a 24 diopter lens is used as a handheld magnifier with the patient viewing an object that is 50 centimeter from the eye and at focal point of the lens. How much larger do things appear to the patient? So all you have to do is to substitute. So ME is equal to DF. So sama na to D nga rin, 50 centimeter. But since 50 centimeter is not meter, so you really need to convert this first to meters. So 50 centimeter. So unsay mo goal na unit is meter. So over pila ka centimeters sa isa ka meter is equal to centimeters. So cancel out these units. So 50 over 100 is equal to 0.5 meters. So we have here D is equal to 0.5 meters. And then for the F, it will remain unchanged because it is already in the dioptric power. So we can now solve for the effective magnification of 0.5 times 24 is equals to 12 times. So with, with this, we can interpret that the 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 patient perceives the images 12 times larger. Okay, and then we have the alternative solution if ever you're interested. So instead of the product of df, it is the division they divide ang focal power to the dioptric power. So if you're not interested in this, you're still free to skip this segment. Okay? So asa man gikan ang ato F? Asa man gikan ang ato F? Same ra ani na F, which is ang 24 value. Ang nakalahi ra kay ang kining D. So since D is equal to 1 over D, ang small d, so is equal to 1 over 0.5. Okay, which is equal to 2. So ME is equal to 24 over 2. It is still 12 times. The same ra, di ba? Alternative lang gid siya. So if D is equal to 0.5 M, then ME is equal to F over 2. Okay. So now let's proceed with the VA-based magnification or the magnification required. So for the formula, we have M is equal to VA achieved over VA goal. Okay, for example, a patient can see only up to 3 over 60. He wants to achieve an acuity of 20 over 60. What is the magnification needed for that patient? So, okay. So, based from this example lang, say wordings, ang 3 over 60 mo ni siya ang ato achieved sa patient, while ang 20 over 60 is our goal. Okay. So the solution is VA achieved over VA goal. So since they are not in the same test distance, which is 3 over 60 and 20 over 60, so we need to find a way for the 3 over 60 to become in 20 test distance. So how do we do that? So all you have to do is divide the 20. Divide your goal, ang imo ganahan na makuha na test distance gikan sa imo kini. So for example, 3 over 60. And you want to have a 20 distance. Okay? So how do we do that? So all you have to do is 20 divided by 3, pila man? Wait, calculus ako ha. 20 divided by 3 is equal to 6.67. Okay, 6.67 is multiplied to 60. So 6.67 is equal times 60 is equal to 400. Diba? Same ra. Mura siya, this is a reverse cloud method. Ako, reverse cloud. Okay? So now, they are on the same test distance. So what you want to do now is only to get what that magnification is needed by the patient to achieve this VA goal of 20 over 60. So all you have to do is to divide the achieved of 400 to the goal of 60. So 400 over 60 is equal to 6.67 times. Okay, another example. A patient can see only up to 20 over 800. He wants to achieve an acuity of 10 over 40. What is the magnification needed for the patient? So, the same process. So, kini, 10 over 40. Okay, ato na sa tubalikon so, ang imo goal na 20. So, 20 divided by 10 to 2 times 40 is equals to 80. Diba? Kuha na yun. 20 over 80. So, since same na sila og test distance of mga 20, so pwede na naman disregard. So 800 divided by 80 is equal to 10 times. So our patient here needs a magnification of 10 times to achieve this kind of acuity. Okay, wow, very good. 27 minutes in and your time for a quiz. So again, pause lang so that you can answer well. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's it for this linear transverse magnification discussion. So I hope you learned something out from it, and God bless on your exams. Thank you and bye bye.